Alright, all I know about transformations in about 10 minutes. Let's go with reflections to begin with. Reflection is a flip, and anytime you do any sort of transformation, it's nice to think about graphing it instead of worrying about memorizing rules. So suppose that we started with the point 4, comma 2. We'll call point A 4, comma 2. Let's run through some of the more important reflections that you need to know how to do. When you reflect over the x-axis, it'll keep the x-coordinate the same, so the brand new point, which we'll call A prime, will be called 4, comma negative 2, and the point would end up in quadrant 4. If we decided to reflect over the y-axis instead, the point would flip to the other side of the y-axis, end up in quadrant 2, and I guess we could nickname that point A double prime. It would change to negative 4, comma 2. When you reflect over the y-axis, it's the y-coordinate that stays the same. Okay, other reflections that you need to know also would be reflecting over the line y equals x. All that will do is take our point, our original point, and trade the x-coordinate for the y-coordinate. I guess the next most important one is called a reflection over the origin, which is sometimes written as capital R sub O. A reflection over the origin will change both the x and the y-axis. It'll bring the point, if you follow the picture, it'll bring the point through the origin and place it or flip it, in this case into quadrant 3, and the new coordinates would be negative 4, negative 2. Alright, the next transformation is a translation. A translation is a slide, and if we started off with the point A, which we would begin with maybe 4, comma negative 5, and they were asking you to translate it according to 2, comma negative 3. What that means, it means to take the x and add 2 to it, take the y-coordinate and subtract 3 from it. So our brand new point A would turn into 2 more for the x and 3 less for the y. Sometimes with the translations, they'll give you a before, they'll give you a point, and they'll give you an after, they'll give you an image, and they'll ask you what happened or what was the rule to get from one point to the other. And in this particular case, with point B, what happened to the x, it got lowered by 1, so that it would be a translation of negative 1. And what happened to the y, it got smaller by 2. So that's one way to write the answer in terms of the rule, or you could write x minus 1, y minus 2. As far as rotations are concerned, with my rotations, what I like to do is I like to just rotate my graph to find the image instead of remembering rules. So suppose that we start at the point 4, comma 1. Right now that point is sitting in quadrant number 1. If I did a rotation of 90 degrees, I will take my paper and twist it a quarter turn to the right. When I do that, my new coordinate is sitting at negative 1, positive 4. So I note where the new point is, where the image is, and then just write it down. If I did a rotation of 180 degrees, that is the same thing as a reflection through the origin. What will that do? That will just change the coordinates. But if I want to actually show it by reflecting or rotating 180 degrees, I'd rotate a half a turn, which is placing my new point at -4, -1. And then finally, if I had to do a rotation of 270 degrees, I would turn my paper 90 degrees, another 90 degrees, and one more 90 degrees. That's 3/4 of a turn, giving me my answer at 1, -4. A rotation that's positive is a twist or a turn to the left or counterclockwise. A negative rotation would turn it to the right or clockwise. So rotating 270 degrees is identical to rotating -90 degrees. So I could have also gotten my answer by just twisting that away. Dilations. Dilations are reducing or enlarging the shape, and a dilation is the easiest one to do. If I did a dilation of 3 and I started with the point -1, 5, the image would turn into -3, +15. Sometimes they'll give you a before and after. So if they said point E was at 4,8 and its image was 2,4 after a dilation, they might ask you for the constant of dilation, and the constant of dilation is asking how many times bigger or smaller are the new numbers. And if you take a look at the before and after, this is a dilation of 1/2. Everything got half as large. There are negative dilations too. I mean, if these ended up being -2 and -4, the constant of dilation would be -1/2, and that's about as difficult as it gets. Dilations are the only transformation that changes the size of the image. For compositions of transformations, they might ask you to blend together more than one transformation, and it can be written with this composition symbol. And if I'm asked to take a point and do a composition like this, the important thing is that you work it out right to left. The first move you have to do is to take this point and reflect it over the x-axis. That would give me 4, -3. When you reflect over the x-axis, the x stays the same and the y changes. Then secondly, I would have to use the translation to finish the question off, which is asking me to add 2 to the x and subtract 2 from the y. So my final answer would end up at the point 6, -9, and that is an example of how you do a transformation with a composition. And a little bit on vocabulary here to finish things off with. Let's begin with talking about what an isometry is. An isometry would be a transformation that maintains or keeps the size and shape exactly the same. And if you take a look at this chart of different types of transformations, every single transformation is an isometry except for a dilation. A dilation changes the size of the object, or most often will change the size of an object, so making it larger or smaller. Another vocabulary word to be familiar with is the word opposite. If a particular transformation is an opposite transformation, it will end up pointing the picture in a different direction. And if you take a look at the choices here, a reflection has the ability of changing the direction of a particular shape, and also a glide reflection, which includes a transformation and a reflection together. Anytime there's a reflection involved, the object will change its direction. If you take a look at the opposite of an opposite, it is a direct transformation. So a transformation is either direct or it's opposite. And then the last vocabulary word I want to show you again or remind you about is orientation. Orientation is the order of the points, and let me show you an example of transformations that keep the order the same. If I have a triangle ABC, the order, in this case clockwise, is alphabetical ABC. As I go around to the right, it's ABC, A to B to C. I can take this picture and I can slide it or do a translation, and still the order still remains the same, ABC. I can take this and I can dilate the triangle. Again, I still have A to B to C as my order. So the orientation is staying the same for a translation and a dilation. If I did a rotation, the order is still the same, A, B, C. The only time it would not be the same is if I did some sort of reflection. So if I reflected the triangle, let's say over the x-axis, now if I trace over clockwise my letters, I get A to C to B. The orientation has changed. So the orientation is the ordering of the letters, and you can see by the guide here that the only ones that will change the orientation will be glide reflections and reflections. For the other transformations, the ordering stays the same.